Task today is to find the sum of the roots of this equation. Now, by a root, I mean something like this. In this particular case, a root would be any r, and r could be complex or real, such that 1 over r to the 10th plus r raised to the 10th power is equal to the constant on the right-hand side, which is 2024. Okay, so that's what we mean by root. Okay. Now, just a root is a solution to the equation. Okay, so we're supposed to find the sum of all the roots of this equation. Now, one tendency is to try to find all the roots, which would be very difficult here. This is a 10th degree equation. It would be next to impossible to do that by hand. Now, but we have a very useful fact here that's taught quite a bit in, say, in an algebra class. This idea of an even function. An even function is defined like this. F is an even function if f at negative x is just equal to f of x. And for completeness, I should put for all x. Now, if you want to, we can call them complex numbers because real numbers are also complex numbers with a zero imaginary part. So we'll put C here if you want. And again, notice that R is, the real numbers are a subset of the complex numbers. So if we define this function, it's even simply because of the even exponent, okay? And it's easy to verify that there's other even functions, but the even exponent is a knockoff. Now, notice that if we define this function, notice that f of x, the way we've defined it here, is very similar to this. And actually, this equation, in the equation f of x equal to 0 are equivalent. Again, y'all, what I'm talking about here is f of x the way we've defined it here. If f of x is equal to 0, it's absolutely equivalent, meaning it has the same solutions as our equation of interest, right? Again, if just think of a 0 being right here, then you could bring the 2024 over, right? F of x equals 0, and you get the very same equation. So f of x equals 0 is absolutely equivalent to the equation that we're trying to solve, all right? Moreover, this equation is even. It is even, and so we get this condition right here that if r is a root of f of x, then we have minus r is a root of f of x, all right? So all of these roots, any roots that may exist, are going to occur in a fashion where they offset each other. And just for an example, let's say R1 was a root. All right, then you would have minus R1 as another root, and that's going to certainly equal to 0, right? So let's say it had a pair of roots. If it has another pair, let's say R sub 2, is a root, well, minus r sub 2 is also a root. And so you can see how this is going to go. Any root is going to be accompanied by its additive inverse. And so all of this stuff has to add up to 0, right? So that is the answer, folks. Again, they pair up. It's a very simple observation. The function itself is even, and it's equivalent to the function of interest right here. So the sum of the roots is equal to 0. Now there's other approaches here. This seems to be the simplest one. We never had to even come close to finding the roots. Another approach might be to multiply through by x to the 10th, and then the x to the 19th term, which contains minus the sum of the zeros, would be equal to 0. That's another approach. But this is very, very direct, and effectively this is the definition of what we mean by an even function right here. And this particular function we worked with met that definition or satisfied that definition. So anyway, that's the end of that demonstration. Thanks for viewing.